peak performance. Designing a PCB is a delicate balancing act. AI is emerging as a powerful tool for optimizing PCB designs, ensuring that they perform flawlessly while minimizing costs. One area where AI excels is signal integrity optimization. AI algorithms can analyze signal paths, identify potential issues like crosstalk and reflections, and suggest design modifications to mitigate these problems. AI can also play a vital role in power management optimization. AI algorithms can analyze power distribution networks, identify areas of high current density, and suggest design changes to reduce power loss and improve thermal performance. AI algorithms can analyze these factors and suggest design modifications to simplify the manufacturing process, reduce material waste, and ultimately lower production costs. Section 5. AI in manufacturing building better boards. The influence of AI extends beyond the design phase of PCB creation. It's also poised to revolutionize the way PCBs are manufactured. By integrating AI into the manufacturing process, manufacturers can achieve higher yields, reduce defects, and optimize production schedules. AI algorithms can analyze vast amounts of manufacturing data, identifying patterns and anomalies that might indicate a drop in yield. AI can also play a crucial role in defect detection. AI-powered vision systems can inspect PCBs with incredible speed and accuracy, identifying even the smallest of defects that might escape the human eye. AI can optimize production schedules, ensuring that manufacturing lines are running at peak efficiency. By analyzing historical production data, AI algorithms can predict machine downtime, identify bottlenecks in the production process, and suggest adjustments to production schedules to maximize output and minimize delays. Section 6. The future of testing. AI ensures quality and reliability. Testing is critical in PCB manufacturing, ensuring every board meets high standards of quality and reliability. AI transforms PCB testing, making it faster, more efficient, and comprehensive. AI systems analyze vast data, identifying subtle patterns and anomalies indicating defects. This helps catch potential problems early, preventing costly recalls. AI optimizes test coverage, ensuring thorough functionality testing. AI algorithms generate test cases covering a broad range of conditions. AI automates tasks like test vector generation and data analysis, freeing engineers for other development aspects. This accelerates testing, shortening product development cycles, and bringing products to market faster. Fewer faulty products reach consumers, increasing confidence in electronics.